Our cosmic dance introducing space-time, space and time. For centuries we believed that these two were separate and absolute entities. Then came Einstein, a revolutionary who dared to challenge the very foundation of our understanding. His theory of relativity revealed a profound truth. Space and time are interconnected, engaged in a cosmic dance, forming a unified entity, space-time. Imagine a giant flexible sheet. This sheet, my friends, represents space-time itself. Every star, every planet, every one of us creates a dip in this fabric. This dip, this curvature is what we experience as gravity. It's a mind-bending concept, but stay with me. Einstein's brilliance was in recognizing that gravity is not some mysterious force acting from a distance, but a consequence of warped space-time. Objects don't simply fall towards each other, they follow the curves created by massive objects in the cosmos. We experience the universe in 3 dimensions: length, width, and height. But what if we could perceive time as a physical dimension, just like the others? What would it be like to see the 4th dimension? Imagine a loaf of bread, each slice representing a moment in time. As you move through the loaf, you experience each slice as the present, with the past behind you and the future ahead. In essence, this is a glimpse of the 4th dimension. Now picture every event in the universe as a point in this 4-dimensional space-time. The past, present, and future all exist simultaneously in this grand cosmic tapestry. We are merely travelers on a predetermined path through this fabric, our perception limited by the constraints of our 3-dimensional senses. One of the most intriguing consequences of Einstein's theories is time dilation. Time, as it turns out, is not absolute but relative to the motion of the observer. The faster you move through space, the slower time passes for you relative to someone who is stationary. Picture 2 identical clocks, one stationary on Earth and the other traveling at incredibly high speeds in space. As the speeding clock approaches the speed of light, time for it begins to slow down relative to the clock on Earth. This is not science fiction, my friends, but a tested and proven reality. Time dilation is not just a theoretical concept. It has real-world implications for technologies like GPS satellites, which need to account for the subtle time differences between their clocks and clocks on Earth to maintain accuracy. We've established that massive objects warp space-time, creating the effect we perceive as gravity. But what does this warping actually look like? Imagine a bowling ball placed on a trampoline. The ball creates a dip, distorting the surface of the trampoline. Now roll a marble on the trampoline. Instead of traveling in a straight line, it will curve around the bowling ball, influenced by the dip it created. This, my friends, is a simplified analogy of how gravity works in the fabric of space-time. The more massive the object, the steeper the curvature it creates, and the stronger its gravitational pull. Section 5: Cosmic Lenses. Visualizing warped space-time. The warping of space-time is not limited to massive objects like stars and planets. Even light, which has no mass, is affected by this curvature. This phenomenon, known as gravitational lensing, provides us with a glimpse into the warped nature of our universe. Imagine a distant galaxy emitting light towards Earth. If a massive object, such as a cluster of galaxies, lies between us and the distant galaxy, its gravity can bend the light coming from the distant galaxy, acting like a cosmic lens. This bending of light can create multiple images of the distant galaxy, or even distort its appearance into arcs or rings. Gravitational lensing is a powerful tool for astronomers, allowing us to study objects that would otherwise be too faint to see. Section 6: Black holes, where time and space collide. Perhaps the most extreme example of space-time warping occurs around black holes. These cosmic behemoths are regions of space-time where gravity is so intense that nothing, not even light, can escape their grasp. Imagine a fabric stretched to its absolute limit, on the verge of tearing apart. This is the fabric of space-time near a black hole. The gravitational pull is so strong that it creates an infinitely deep well in space-time, a point of no return known as a singularity. As you approach a black hole, time dilation reaches its most extreme point. Time for an observer at a safe distance would slow down to a crawl relative to someone near the black hole. From the perspective of an observer falling into a black hole, time would continue to flow normally, but they would witness the universe around them accelerate and distort in bizarre and unimaginable ways. Section 7: A Universe Unveiled. Seeing the unseen. If we could truly perceive the fourth dimension, our understanding of the universe would be forever changed. We would witness the intricate dance of spacetime, seeing the universe not as a static backdrop, but as a dynamic and ever-changing entity. Imagine looking up at the night sky and seeing the paths of planets not as simple ellipses, but as spirals through spacetime, their trajectories influenced by the gravitational pull of the sun and other celestial bodies. We would witness the birth and death of stars not as isolated events, but as interconnected threads in the grand tapestry of spacetime. Galaxies would appear as swirling vortexes, their graceful movements shaped by the invisible hand of dark matter and the expansion of the universe. Section 8. The passage of time, a new perspective. Our very perception of time would be revolutionized. We would no longer see it as a linear progression from past to present to future, but as a fluid and malleable dimension, intricately intertwined with space. Imagine seeing the aging process not as a gradual decline but as a journey through spacetime, our bodies tracing unique paths through this cosmic fabric. We would see the interconnectedness of all things, how our past actions ripple through time, influencing the present and shaping the future. This new understanding of time would profoundly impact our relationship with the past, present, and future. We would no longer see them as separate entities but as interconnected facets of a single unified reality. Section 9. Implications for exploration and understanding. The ability to see space-time would have profound implications for our exploration of the cosmos. By understanding the curvature of space-time, we could navigate the universe with unprecedented precision, using the gravitational pull of celestial objects to propel our spacecraft across vast distances. Imagine using the warped space-time around black holes as gravitational slingshots, propelling our spacecraft to near the speed of light, allowing us to reach distant star systems within human lifetimes. Furthermore, by studying the subtle distortions in space-time, we could unlock the secrets of dark matter and dark energy, the mysterious forces that govern the evolution of our universe. Section 10. The limits of perception. Can we truly see spacetime? While the idea of seeing spacetime is tantalizing, it's important to acknowledge the limitations of our human perception. Our brains are wired to process information from 3 spatial dimensions and 1 dimension of time. Visualizing a 4th spatial dimension, let alone perceiving the complex warps and curves of spacetime, may be beyond the capabilities of our current evolutionary stage. However, this doesn't mean we should cease our quest to explore and understand the universe. Through scientific inquiry, mathematical models, and our boundless imagination, we can continue to unravel the mysteries of the cosmos, even if we can't directly perceive them with our senses. Section 11. A Universe of Wonders, the Ongoing Quest. The quest to understand spacetime is a testament to the power of human curiosity and our relentless pursuit of knowledge and discovery. While we may never see spacetime in the literal sense, the journey of exploration and discovery is no less awe-inspiring and captivating. By embracing the wonders of the cosmos and nurturing our thirst for understanding, we embark on a journey that transcends the limitations of our physical senses, a journey that brings us closer to unraveling the profound mysteries of the universe we inhabit and cherish. So, my friends, let us continue to explore, to question, and to marvel at the intricate workings of the universe, for it is in the pursuit of knowledge that we truly begin to grasp the vastness and wonder of the cosmos and our place within its grand and magnificent design.